question, that would be, I would say that there basically are a vast amount of potential possibilities there, and through chance, in some sense, we have nature has searched for some of those potential possibilities, has found some of them. There are probably many, many others that we don't even know about. So they are restricted by laws of nature, but they're varied by the chance things that are happening out there. To predict what all those possibilities are, I think would be very difficult, because all those possibilities are basically, the number is so vast. You know, it's like the giant search space of possibilities that you know, I don't think you could predict it.
What if we got that huge computer?
Yeah, well, the computer gets bigger and bigger. At this point you can think of the universe. Think of it this way: the universe is, in some sense, a giant computer. It's computing the possibilities as we speak, and it has found some of them. So if you would need a bigger computer than that.
There's some evidence that life is probable given the right conditions. I mean, it started on Earth very soon after the conditions were physically suitable. Very soon after we stopped getting bombarded all the time, and the temperature fell below boiling. Life started. We have signs of life within a few 100,000 years at that time. So life might be very probable. That's not to say intelligence is.
Yeah, I mean, I would probably agree with that, although, you know, to be a really good scientist, you have to admit that you don't know that. But I would give it a pretty high probability that that's probably true. For example, I mean, all these experiments people have done where they just put some not random, but certain molecules in a big flask and just sap them with something, and you end up with, not with life, but you end up with very complex molecules which in an equilibrium situation would never form. But in a non-equilibrium situation, with a constant supply of energy, complexity just happens. It just happens. And so I don't see why adding a few 100 million years to some experiment like that on a vast scale wouldn't come up with some, you know, RNA molecule enclosed in some lipid bilayer that reduces itself or something.
You know, the fine-tuning argument on the other side of this question,
Uh-huh.
the fine-tuning argument goes, well, there are some constants that they were just slightly different, the rate of expansion at the Big Bang, the attraction of gravity, if they were just a smidgen, I mean like 10 to the minus 27th different, then matter wouldn't have clumped, and if it didn't clump, you're not going to get life, and so on, you're not going to get intelligent life. So on the other side of the equation, you have all these years and all these planets for it to happen, but you have a very, very small probability, so the argument goes. These constants are slightly changed.
They're different. I know this is out there, but there's different people. I recommend read somebody called Victor Stenger, and he's a physicist, maybe one of those reductionist physicists, you know. But he basically says a lot of this fine-tuning stuff is not really as people make it out to be. He says, you know, you can change some of those parameters, and you would have stars that might be a little bit different, but you still have stars. And maybe life would be based on, you know, magnesium or something. I mean, the point is that this vast search space, you know, that comes back to your question. If things, the parameters would be different, we don't have that computer to really compute what things would be looking like. Sure, there are some parameters, if you change them a lot, like you said, matter might not even come together at all. So that's the one thing that people say, that it's not really as fine-tuned as you would think. And we don't really know what some of those parameters would really do. Maybe we'd have just a different type of life. Maybe life that's the size of a galaxy, who knows? I mean, it could be anything in a different universe. The other thing is that we may have multiple universes, who knows? We may just, you know, the reason that we are here, and that's what they call the weak anthropic principle, right? We are here because this is where we can be. But if we have a universe where any different, we wouldn't be here to ask these questions. So there's other universes that may not have worked out that way with other parameters. There are no people to ask questions. They're just
the probability issue. It doesn't matter about that. That inference principle is silly. It's a question about whether it's likely we'd have a universe that would support life. And if, yeah, I agree with you. I mean, it's relevant whether they're right about these claims about the slight difference in these parameters would make a big difference. that's really crucial. But if they were right, just do it hypothetically, then it means it's very unlikely. Well, but then if you had zillions and zillions of universes, it counterbalances the unlikelihood. But all of this is sort of up in the air. I don't know. I think I'm skeptical about this thing.
Oh, I'm completely
have enough
skeptical.
evidence.
I mean, I'm completely skeptical about multiverses and all that kind of stuff.
Yeah.
But I'm not dismissing it. It's
Sure.
Yeah, I mean, obviously that's why why we're in the business. I mean, you know, we had all the answers, and you know,
I just
wouldn't have a job.
I just want to counter the argument that says, oh, it's very likely we'd have life because, and it starts with the assumption the world is the way it is.
Yeah.
Yeah, but
yeah,
then
from
the
that
other
assumption,
question
I think that was the point that was made. Is like if the world is the way it is with these physical laws and those parameters, then it seems like just from our one experience that we have, which is this one planet,
Right.
so far, that it seems likely. You know, that's pretty much all we can say.
Do you see the reduction of biology to physics as different from reduction of biology to physics as different from, say, the reduction of sociology to psychology or possibly psychology to biology?
Yeah, well, now we get into higher levels here, you know.
Hierarchy of science.
Yeah, that's why I stayed away from it. One of my colleagues, I think it didn't come, said like, oh, you're going to talk about how mind can be reduced to physics or something like that. Which, as you may have noticed, I completely stayed away from that, you know. That's, you know, you're getting into this higher. I mean, I said already, the interaction of animals, you know, and ecology is physics is useless. I mean, in doing something. And I think even in understanding mind is yeah, I can understand action potentials and how you know, electrical signals run through my neurons. But does that really understand this picture I have of you right now when I look at you, and that I can understand that you are a person? And is that, can I really, I mean, there's obviously neurons firing and they're all doing something. We can maybe understand at some point, but then it's probably not physics that makes us understand it. And then you have multiple humans interacting with each other, you know, all with their own minds. But you know, still I think that the hierarchy is there. So already we have neural networks that we can train, right? People build neural networks and they can train them and they can recognize things. So we understand a little bit on a rudimentary level how it may work, how our brains may work. And so once we know how brains work, maybe we can understand some of the behavior of how people behave. Once we understand the individual behavior, we can then understand how groups of people, on some level, I mean, it's our only chance. If we don't try, then we never understand anything, I think. I don't know.
That the hierarchy between biology and physics may be much more profound or not?
I don't know which one is more profound. I think the hierarchies are all profound in their own way, you know, but they're all there.
They're different.
Yeah, they're different, sure. Yeah. I mean, that's the thing about complex systems. I think the one problem that we are looking for the laws of complexity. In my opinion, there are no laws of complexity, because every complex system has its own laws of complexity. Some level. There's some laws, maybe, but you know, even in physics, the complex systems, turbulence or stuff like that, they're all, each one you have to find the laws to fight that system. I don't know if there's universal laws, but I'm not really sure. Okay.
Let me explain my previous thoughts.
Yeah.
Go ahead. Let me throw out a completely crazy view, and it's something along the lines of your bad reductionist might hold. And then I want to ask what your response to this view is, and the things that you said didn't seem to work. Here's a completely crazy view. There are no tables, chairs, humans, molecules, even atoms. There are only subatomic particles. There are only quarks and electrons. Those are the only things that exist.
Okay.
So, okay, there's a crazy view. Your view says, no, there's all these other things. There's hydrogen atoms, water molecules, protein molecules, cells, organisms, all that. Why? Well, because when we look at them, we find that we can't understand these things without we are psychologically incapable of understanding everything in terms of just the quarks and electrons alone. That seemed to be your kind of non-reducibility, and that seemed purely psychological.